We've been working with polynomials. We have multiplied them. Well, first we added them. We can only add like terms. The exponent does not change. Then we multiplied them and discovered the rule that when we are multiplying monomials, we add the exponents. Multiplying monomials, we add the exponent. Then we did the power rule. When we're raising a power to a power, exponent to exponent, we multiply the exponents. So today we're going to learn what happens when we divide them. Let's just write one out and look at it. What if we're doing x to the 6 divided by x to the 2nd? Well, this means x times itself 6 times. This means x times itself 2 times. Now, we can cancel these because x divided by x is 1. Anything divided by itself is 1. Cancel those. What do we have left? We have x to the 4th. So the division rule is opposite of the multiplication rule. The division rule is to subtract the exponents. It's that simple. So let's do another one. Let's do x to the 20 divided by x to the 6. We don't want to draw out 20 x's and 6 x's and cancel, so we can use the rule that all we do is subtract. What if we had more than one letter? I'm going to get a to the 10, b to the 8, c over a to the 2, b to the 3, c. So just like in multiplication, we kept the letters together. We're going to do the same in division. So let's look at the A's. 10 minus 2 is 8. Let's look at the B's. 8 minus 3 is 5. And look, our C's cancel. So this is our answer. Now what if we throw some numbers in there, some coefficients? We're going to put 10 a to the 2nd, b to the 3rd, over 2ab. Well, numbers do what numbers have always done. The rules with numbers don't change. 10 divided by 2 is 5. But exponents, the rule is to subtract. Remember, this is an imaginary 1. 2 minus 1 is 1, so I just have a. This is an imaginary 1. 3 minus 1 is 2. There's my answer. So what if you'll notice in these, the bigger exponent was always on the top. So what if I had one, let's say 20a b to the 5, excuse me, over 4 a to the 4th b. If you'll notice in this one, of course, this a has an imaginary 1. Do you see how the bottom exponent's bigger? All right, we start with the numbers. Let's divide them. 20 divided by 4 is 5. The b's, there's an imaginary 1. 5 minus 1 is 4. But here's the interesting part. We leave the answer where the bigger exponent was. So 4 minus 1 is 3, but that a to the 3rd should be on the bottom. It should stay in the denominator. So we leave the answer where the bigger exponent is. B had the bigger exponent at the top, so it stayed in the numerator. A had the bigger exponent at the bottom, so it stayed in the denominator. So what if this happened? Let's see. What if I had x, y to the 2nd, z to the 5, over x to the 3, y to the 4, z to the 10. All the ones in the bottom are bigger than the top. But the top, it is a fraction. It has to stay a fraction. Let's say 3 minus 1 is 2, 4 minus 2 is 2, 10 minus 5 is 5. What goes in the numerator to show that I have a fraction is a 1. We have to put a 1 as a placeholder. One more thing I want to show you today, that is dividing. I want to show you the zero property. Remember I said the other day that I would show you, we would talk about when the exponent's 0. So if I have x to the 0. I want you to know anything to the 0 power is 1. Let's say I have some big hairy thing in parentheses, but the whole parentheses is raised to the 0 power. That'd be 1. No need to do any math. What if I had just one term raised to the 0 power? Well, then that one term, that one term becomes 1. X to the 0 is 1, so can't I just cancel it out because anything times 1 doesn't change? And then I have 3y to the 3rd. Let me show you why that works. The reason that works is, let's say we had this. Would you agree with me that anything divided by itself is 1? So that should be 1. But what happens when I use the division property and subtract the exponents? 4 minus 4 is 0. And anything divided by itself is 1. So there's your 0 property. If you forget, make up any number you want to on your calculator. Well, let me clear that out. Make up any number you want to on your calculator and put it, use this little caret button, to the 0 power. Your calculator is going to tell you 1. So if you ever forget what that is, just use your calculator to do that. So division, you subtract the exponents 0, anything to the 0 power is 1.